Again, we're going to use the single line option here. All right. So now let's go ahead and grab our map, which is going to be that. Map equals map regex dot match data dot trim dot value dot trim and string program equals program regex dot matches on data dot no overload for method join. Oh, hang on. Join. No, correlates the other. No, that's not what we want. Empty string dot join. All of that. No. Cannot convert from. Oh no, it's going to be right. String dot join on nothing. That. Maybe? Empty character literal. Yes. I know it has many overloads. Empty string. There we go. All right. So now display map. Display program. Let's see what we got there. There's our map displayed, and then there's our program, all in one mighty line. Beautiful. Okay, we don't need these displays. So we now have this as one long string. Actually, hang on. String, map string, because we're not done yet. And in fact, neither of these are done yet. Program string. Okay. We're going to take our map string, and what I want to just do quickly is get this into something that I'm going to be able to manipulate any given position of easily. So, we've done this before. We converted some strings very early day. We did this with a map. Day 1, day 2, 3, 4, 5. Maybe, no, was it 4? No, I don't think it was, but I'm just going to double check. No, 4 was not the day when we did that. 5, 6. 6 is the day where we did it. We had to generate, turn the thing into a character array. All right. Yep. All right, then we split that. Yeah. So let's just grab these things here. Oh, and also we can also grab this. Okay, we got some useful stuff here. All right. Direction, coord, step, set with those directions. Okay. String map is going to be map string dot split there, then string map dot select line dot to char array dot to array, and then we have the char thing map. Okay. Then we've also got here program string. So what I want to do here is going to be list of direction program equals program string dot select C goes to C switch goes to direction dot up. Oh, hang on. Oh, right. Yep. Also, I just need to see two lists at the end of all this. Okay. Yep, not all possible values are covered there. Great. All right. Up. Direction dot right. Direction dot down. And direction dot left. And then otherwise, invalid data exception. I don't expect that to happen, but you know. Oh, invalidated, fine. Argument exception. Throw system.argument exception. Great. All right, so now let's go ahead and instead say map. Run that. Ooh. Oh, right. And there's our map. Great. And then let's also look at our program. There's our program. All right. So we've parsed our map and our program into some useful things. Onward. And so what I just want to do here is we're just going to say void process step direction. Actually, no. It's going to be char array process step. And we're going to have, instead of this being map, I'm going to have this be initial map. Just that we're not mutating things too much because we got into trouble that way before. There we are. So we're going to process step. We're going to do that. And actually, no, I am going to have it be void. It's going to mutate because I think life will be easier that way. But this way, at least we know that we'll know that we're passing it in here. So, okay. And to avoid, actually, let's go ahead and do a quick thing here. Using state equals. Hey, bald bearded builder, welcome. I'm Jason. I stream as Brain Better, and today I'm doing Advent to Code. This is pretty much usually a programming stream, but today it is a programming puzzle stream. So let's throw the state in this thing here. All right. So the state is the combination of the map and coord position. Because what I don't want to do here I'm not going to play with the joy here. This is not the right time for that. That's more a mood at the end of that thing. Let's put on some nice classic programming techno. Plan to the shapes. Here we go. Oh yeah, we're using this is a C# based notebook. This is called Polyglot Notebooks. It's pretty cool. So I initially started doing it this way in order to teach myself how to use these notebooks because I wanted to use them for some teaching I was doing, and the thing I was doing with that ended, but I'm still using the notebooks, and it's super fun. Also, thank you for the follow, Polymathic Man. Yeah, I love a lot of languages. It is weird doing notebook style programming in C#. It is so weird using a language that is like super compile-y for it, but it's being fun. I'm enjoying it. All right, so here we go. Our state is the map and the position because I don't want. We could spend a ton of time searching for where that bot is on every cycle. So let's just pass that thing through. So instead of that, we're going to actually say state, state, direction, direction. Okay. So now what we want to do is, okay, is the state valid? So we're just going to check here that if, so let's just say here, right. Let's unpack this first. So var map equals state dot map, var pause equals state dot position, and lowercase those because they're coming off of there. Okay. So now, first we just want to check is if map sub pause dot r pause dot c does not equal at invalid operation exception bad state frowny. Oh, it doesn't know. I'm not going to draw it to a frowny because it messes up. Okay. We just want to make sure that the position we've been told for where the bot is in fact where the bot is. Okay. So now what we need to do is we need to say, we're going to look at that direction. So let's go ahead and let's get yeah. Coord vector equals, so this is kind of the vector in which we're moving. We're just going to say, right. We have that step constant upstairs. So it's step sub int direction. So we read the enum as an int, and we get the step that would move us in that direction. So now what we want to do is what's in that direction? So options, possibilities. It's empty. There's a, what do they call them? Are they crates? What are we calling these? Oh, boxes. There's a box. There's a wall. Okay. This is actually really easy now that I think about it. All right. So if so let's go, yeah. We're going to switch on map sub. All right. So the target target equals pause, or add pause vector. All right, and we need to now look at the map and the target position. Target.r, target.c. Actually, no, I'm going to make myself a little bit happier here. No, I'm not. I was thinking about giving myself a helper for doing that little bit of dereferencing the tuples, but I decided not to. All right, so we're going to switch on that. If it's a dot, then we have a nice easy case. We're going to say swap, pause. Why do brackets there? Pause, target. What's swap? We'll write it. Break. Case. Next possible case is that this is a wall. Nope. Break. Nothing changes. Or it's a box. All right, and if it's a box, what we basically have now is we need to find out what's beyond it. So what we're going to do now is while, so we're going to say, yeah, coord coord pushed equals target while pushed, or while, hang on, no, I am going to write that helper. Car map at coord C, or coord goes to map sub coord.r coord.c. That will make my life happier. So if map at pause isn't that, and then we're going to switch based on map at target. Just given the number of these I'm going to need. So then here we go. Yeah. While map at pushed is equal to O, add pushed equals add pushed vector. Keep going along it until we come to something else. Now, if map at pushed is a wall, break. Or actually, if map at pushed is a wall, actually, we're just going to, map at pushed. Close those parens. Get the parens right. Okay, so if the map at pushed is a wall, then, yeah, we can't do anything. So, actually, really what we want here is if map at pushed is a dot, that's where the interesting stuff happens, yeah. Implicit else. What if we just don't? So in that scenario, we're going to say we now need to do okay. We're going to do two things. We're going to say what I'm just going to say here is we're going to swap pause. So pause goes to target, goes to pushed, goes to pause. So we're going to do a three-way swap. Okay, so now we just need to write swap. And we need to write both the options for swap. So let's go ahead and say void swap coord A, coord B. If we do that one, what's going to happen is we want to say that map at, actually, for this one, we don't want to use map at because we're actually going to do, we're going to do a tuple swap here, which actually means this is a one-liner, isn't it? Map coordinate, map a.r, a.c, comma, map b.r, b.c equals b, b, a, a, and that's a swappy assignment right there. Now, void swap. Actually, I'm just going to copy this. Swap ABC. All right, so this one's going to be a little bit bigger. We have AR, map A, map B, map C. So A, right. So whatever's in A, yeah, position goes to target. Yeah, A goes to B. So B gets what was in A. So it's going to be, yeah. B gets what was in A, C gets what was in B. And then A gets what was in C. Oh, you can't do overloads here. Okay, fine. We can swap. Then we can also void try swap. Hello, try swap. Okay. Cool. So there's all of that. I hope that swap works the way I want it to. I'm not going to test it ahead of time because this is advent of code. We don't need to test things ahead of time. We'll test them when we test them. Okay, but there's a few things we need left before we can do process step. We need to actually build ourselves a state. So we need a quick thing here. State. Yeah. State equals. And actually, I guess, right. This takes a state, and it probably does need to return. Yeah, because position, that's not going to be. Is that by ref? I don't know. Our C#. Are tuples a reference or a value type? Ah, system.value tuple. Okay. Tuple types. How do I make something a value tuple? Or no, wait. Or value tuple or ref tuple. Okay. Tuple types are value types. Tuple elements are public fields. That makes tuples mutable value types. Okay. Group method results in a tuple return. Yep. Okay. Use instead of anonymous types. Group loosely related data elements. Yep. Tuple field name. Okay. As with Hamish deconstruction. Yep. Great. Okay. Tuple equality. Tuples as out parameters. Aha. Aha. System.tuple. Right. Okay. System.tuple types are reference types. And systems.tuples are immutable. Okay. We'll see what happens. I might have to do a little bit more work to get the state to do that thing, but our initial state is going to be map, comma, and then we need to find the location. So let's go ahead and say coord find bot. Oh, no, wait. It's rows are height. Columns are width. If map sub RC is the @, return RC. No robot? Okay, so now I can just say, yeah. Actually, I am going to have this thing, yeah, take a map, because that'll make my life easier here. So, right. Find bot. And then, right, we need map, where we have initial map. So, right. No, car map equals actually no, hang on, I just want to, can I just clone array dot copy initial map. Can you do that? The name initial map does not exist in the current context. Oh, right, because we didn't rerun that. Okay. Then we rerun this. Okay. That thing did semicolon, right. Find bot map. Okay. No overload for copy takes one argument. Okay, fine. Initial map.clone. Can you do that? Right. And clone is not the type safest of things to do. We'll find out what happens here. Run. Great. And then if we just say state, run. Okay, there's our board. And item 2, it says 4-4. 4-4 sure does look like where that thing is. Okay. And the fact we've got a wall around the border is nice. I don't need to do any bounds checking because we feel good about the inputs. So now what I just want to do here is we're going to say, right. Process step, state, program dot first. Okay. And then what I want to do here is, yeah, we're going to say display state before we do that, and then display state after we do that. Run it. Okay. The bot has stepped one position left, pushing the thing in front of it. The only problem is we didn't update the bot's position. So we also need to say, yeah, if the bot moves, we also then just need to say that, yeah. Because position, so we actually want to update it. So we're going to actually say pause.r. No, actually, can I just say, yeah, pause equals target. And I also then want to just say here, if the same thing happens, if we do a push, pause equals target. Save that. Let's see what happens. I think this might not work. But it did. Wait. Oh, no, hang on. Run all. We did not get a copy. That thing stably had, yeah, that persisted the change. So this clone did not work. C# clone 2D array. You can use link to make a copy. Okay. Right, this is a jagged array, so this should work. All right, yeah. Fine by me. That's a nice easy idiom there. Deep clone. All right. Run all. And now if we rerun this one here, yep, it did not persist that thing because now it's operating